Yes, sir.
Okay, thank you. In the previous class, we have seen what is the basics of operational amplifier, and then we have seen the operational amplifier is nothing but a voltage amplifier. That means we will be providing an input voltage, and with respect to that we will be getting an output voltage, and this output voltage will be nothing but the gain of the amplifier multiplied by the input voltage. Okay, so we have seen the ideal and practical operational amplifiers, what is their characteristics, and after that we have seen what is the different modes of operation. So into that different modes: single mode, single ended, double ended, and common mode. So common mode is where both the inputs are same. So two input terminals are there, both the inputs are same, then it will be called common mode. Okay, if the inputs are different at both the input, it will be called double ended. So double ended, or it is called differential mode. So this is will also be called as differential mode. Just a minute. Just wait for a minute. Okay, so sorry for the disturbance. Okay, we will be starting with it. So in the previous class, we have seen the basic of operational amplifier. There are different modes we have seen. So in that we have seen single-ended. So these are single-ended if a single input is applied to the input terminals. So these are single-ended. In that single-ended, it is like inverting type or non-inverting type. If the inputs applied is to the inverting terminal, then it will be called inverting amplifier. If the input is applied to the non-inverting terminal, it will be non-inverting amplifier. And if the input is applied to both the inputs, it will be called differential or double-ended, or we will be calling it differential mode. We will call it differential mode. And if the input is applied to the both input terminals, but both the inputs are same, then it will be called common mode. Okay, and also we have seen how it behaves. Basically, this is the symbol of operational amplifiers. Two different inputs are there. If input V1 and V2 are being varied, with respect to that, what will the output? So output will be either greater than 0 or less than 0 based on the polarity of the input terminals. So input terminals we are applied. So this input is connected to positive side, then it will be output is positive. If connected to negative side, output will be negative. If both the inputs are connected, but if the polarity on the negative side is higher, V2 is higher, then output will be negative. So this we have seen. So we will just see some concept further. So one of such concept is like, here we will see different cases. So if it is an ideal operational amplifier, we have called it like the gain, that is voltage gain that will be there, AV is infinity. So if AV is infinity, then what will be the case we will see. So in most frequent cases, if ideal operational amplifier is given, then we need to consider AV equals to infinity. So in that, how this ideal amplifier, operational amplifier will be behaving, we will see that. So first of all, its name is operational amplifier. So why it is named operational amplifier? Anyone? Why it is named operational amplifier? Yes, anyone? So basically, this operational amplifier is invented for execution of mathematical operations. That's why it is called operational amplifier, because it was invented for executing mathematical operations. That's why it is called operational amplifier. Okay, because it is basically used in that cases, like it was just used for mathematical operations like addition, subtraction, multiplication and logarithmic functions. So these are different applications of operational amplifier. Basically it was invented for that mathematical operations only. That's why it was called operational amplifier. Okay, so here we are going to see the effect of AV equals to infinity. This is our operational amplifier. This is the symbol. Here this is negative and this is positive. Two different inputs are there. So this is V2 and this is V1, and the difference between these two will be called Vi. So Vi will be V1 minus V2, and this is your output, and this output will be gain, whatever gain is there, gain multiplied by the input. So with respect to that, we will be having the input output relation, like how the plot is going to be. So we'll just see the plot, how the ideal plot will be with respect to different input and output conditions. So this is your input voltage and this is your output voltage. So if the input voltage is, for the ideal case, if the input voltage is just greater than 0, so in this case, if Vi is greater than 0, Vi here is V2 V1 minus V2, Vi is V1 minus V2 from there. Okay, so when Vi is greater than 0, that means if this is the 0 point, if Vi is greater than 0, whatever the case is there, the output will be positive. So that positive voltage, in case of ideal case, if Vi is just greater than 0, the output will be positive, and this positive will be a constant positive voltage. This will be the output if the input voltage is positive. Similarly, if the input voltage is negative, the output will be a constant, and that constant will be a negative constant voltage. So this will be the negative. So this value of positive output will be the plus V set, and in negative case it will be minus V set. So what is this V set? We have already seen what is V set. So V set is nothing but the biasing voltages applied to these operational amplifiers. So it is not shown into the symbol, but it is there. So whatever the positive voltage, maximum positive voltage that we are applying is called plus V set, and the negative applied voltage is called minus V set or negative V set. So if the input voltage is greater than 0, in case of ideal, whatever the output voltage will be there, that will be suddenly reaching to the plus V set. If the input voltage is negative, then the output voltage will be minus V set. So this is the case of an operational amplifier if it is working as an ideal mode. But in the case of practical mode, it is showing a different case. Like once input is switching to 0 or positive greater than 0, then at that time it will not be suddenly reaching to plus V set, but it takes some time to reach. So this will be the curve for practical. So practical will be superimposing this, but it will be initially taking some time to increase to plus V set. Similarly, in the negative side, it will be taking some time to reach to minus V set, and then it will be going to be constant to minus V set. So this green one is for practical case, and this one will be the ideal case. So from there you can just see like how the behavior of an operational amplifier will be there. So if this is the ideal case, it will be just switching to plus V set or minus V set. So always the output of an operational amplifier without feedback, there is no feedback there. So without feedback, output will be either plus V set or minus V set. Okay, and if it is a practical one, it will be taking some time, because in practical case the gain will not be infinity. That's why it is not going to switch plus V set, but it will be taking some time, and it will keep on increasing. There will be a linear relation. As we are increasing the Vi, the output voltage will be increasing. So if the output voltage after multiplying the gain is less than plus V set, then it will be a linear relation. If the gain multiplied by the input voltage is either equal to or greater than plus V set, the output will be a constant plus V set. Okay, so we will take some examples. Okay, so suppose example cases we will be taking. Example cases like, suppose if the case of ideal case, we are considering the ideal case. Okay, so if it is an ideal case, if V1 is equals to 2 volt and V2 is equals to 5 volt, then what will be the output? If the operational amplifier is an ideal one, then what will be the output? Yes, anyone? By using this curve, input output transfer curve, you can just identify what will be the output if the V1 is 2 volt and V2 is equals to 5 volt. Yes, anyone? This is the case of ideal. Are you getting the question? Yes, anyone? Hello. Am I audible to everyone? Hello? Hello?
Minus
Hello?
3 AV.
Yes, what will be the output?
Sir, minus 3 AV.
Minus 3 AV. Okay, so one option is minus 3 AV. Next, any other student? So basically here it is an ideal one. So AV will be equals to infinity. So any other student, like what will be the output if we are applying V1 equals to 2 volt and V2 equals to 5 volt? So either you are not getting the concept or you are not listening to the class basically. Okay, what is the case then? Either you are not listening or you are not getting the concept. Sahil Kumar. Sahil, are you there? Hello. Okay, I think Sahil is not there. Swapnil. Swapnil is there. So whatever is the answer, you can just let me inform so that I will be getting whether you are getting the concept or not. So I think no one is there in the meeting and they are just logged in and they are not listening to the lecture. Okay, so no problem. So from next class onwards I will be doing something other so that you might be listening. Okay, so here if V1 and V2, V1 is 2 volt and V2 is equals to 5 volt, at that time by using the curve you can just see. So here input voltage will be V1 minus V2. So V1 is 2 volt and V2 is 5 volt, so it is minus 3. So that means V1 is negative. Minus 3 volt means V input voltage V in is equals to negative. So if V in is negative, this is the curve. So V in negative means V in lies between the left side of the V naught, or V naught equals to our y axis we can say. So if it is in left side or negative side, the output will be the minus V side. It is shown here by using the curve. So it will be a constant that will be minus V side. So output will be minus V set. Okay. Similarly, if V1 is equals to 5 volt and V2 is equals to 2 volt, then at that time V input will be equals to V1 minus V2. So V1 is 5 volt minus 2 volt. So V input is 3 volt. So if V input is 3 volt, it is implies like it is a positive value. So on positive side, always the output will be equals to plus V set. Okay, so this is the case of ideal one. If it is the case of practical one, so in case of practical one, there will be a value of AV that will be closer to you can say 10 to the power 6. 10 to the power 6 is the AV in case of practical case, or suppose 10 to the power 6 is there. Suppose AV is 10 to the power 6 in case of practical. It will not be an infinity. So if this is the case, we need to consider like V1 is equal to suppose 5 microvolt is there, and V2 is equals to 2 microvolt is there. If this is the case, then we will be getting the V input will be equals to V1 minus V2 will be 5 minus 2 is equals to 3 microvolt. If this is the V input, then V output will be equals to gain multiplied by V input. So gain is here 10 to the power 6 multiplied by V input. So V input is 3 microvolt. So it is nothing but what is it? It is 3 volt. So V output is 3 volt. Okay. So if suppose it is practical one where gain is given here and plus V set is given suppose plus 15 volt, and minus V set it is given minus 15 volt. In that case, as the output is coming out to be 3 volt, and this 3 volt is less than plus V set, because plus V set is 15 volt. So the output will be 3 volt only. But in the second case, suppose in the case 2, there is a, this is case 1, case 2, the case is like V1 is coming out to be suppose 50 microvolt, and V2 is equals to suppose 5 microvolt is there. So in that case, if we consider the V input will be 50 minus 5 is equals to 45 microvolt, and then V output will be AV multiplied by V input is equals to 10 to the power 6 multiplied by 45 microvolt. So V output is coming out to be 45 volt. So if output voltage is 45 volt and this is greater than plus V set, that is 15 volt. So as the output voltage is greater than plus V set, it will not be like the output will be 45 volt. The output will be then by using the curve. So as it is going to keep on increasing, it was initially 3 volt, now it is coming out to be 45 volt, but it will not going to 45 volt as going to be increasing. If it goes beyond this plus V set, that is 15 volt, it will be a constant. So now in that case, the output will not be equals to plus 45 volt, it will be equals to, the output voltage will be equals to plus V set, and thus plus V set is plus 15 volt. So output voltage will be plus 15 volt. So this is the concept that we can get from the output curve, input output relation, the curve that we have in case of practical and ideal case. Okay. So there is some questions related to the topic that we have gone through. So it is true and false related questions are there. So just go with the first one, that is an ideal operational amplifier has an infinite input impedance. Whether it is true or false, can anyone respond?
True, sir.
Okay, it is true. So the ideal op-amp has infinite input impedance, it is true. The second one, an ideal op-amp has very high output impedance. What is this? Is it true or false? So we have seen in case of operational amplifiers,
False.
the output, yes, output impedance will be low. That means output impedance would be 0 in case of ideal op amp. So okay, so it is not high, it should be low. So it is a false statement. The next one is the operational amplifier can operate in both differential mode and common mode. Is it true or false? Yes, anyone? Yes. So operational amplifier can operate in both differential mode and common mode.
Sir, I think it's a differential amplifier.
No, it is operational amplifier. We have seen different modes of operation of differential amplifier. So
So
one was
it can
single-ended,
operate in
single-ended,
both the modes, na sir. So it
yes,
should be
double and common. We have
yes,
seen these
yes.
modes. So double mode is also called differential mode.
So it can
Okay,
operate in
so it
both the
can operate in
modes.
both differential mode and common mode. Okay, so this is a true one. Okay, so the next concept now we will see is virtual ground and virtual short, that is there in case of operational amplifiers. So for that we will be taking the case of ideal op amp. So if it is an ideal op amp, we have seen the gain should be infinity in case of ideal op amp. If this is the case, we will just go like how we can relate the relation between the input and output. We have already seen also this. So negative and this is positive. This is V2 and this is V1, and the difference is V input. So this is output. So we have seen if the V input, if we want to take from here, V input will be V1 minus V2, and the output voltage is gain. The gain, the gain is infinity here. So okay, so gain multiplied by the input voltage. So this is the relation of input and output in case of operational amplifier. But here we have taken like if it is an ideal one, so the gain is infinity. Gain is infinity, and suppose input voltage is there, and this input voltage is going to be the difference of V1 and V2, and at that time suppose output voltage with respect to that we are getting is a finite voltage, suppose 5 volt. So suppose we are getting a output voltage that is 5 volt, and we have gain infinity. So from there if we want to find out the input voltage, so by putting these two values into this relation, we can get, suppose this is the equation 1 and this equation 2. If we want to put this value, in equation 2, we can just get the relation. So V output we are having 5 volt, and AB is having infinity. AB is infinity, and this is V input. So from there if we want to find out V input, it will be 5 divided by infinity. So 5 divided by infinity will be equals to 0. That means if output is 5 volt and at that time gain is infinity, then input should be equals to 0. That means if input is 0, at that time the output will be equals to 5 volt, if AV is infinity. From there we can get like with 0 input also we can get some output. Okay, so that means there can be or there is finite output even for 0 input. So for 0 input also we are getting some output. Okay, so we can just put the value like V input is 0, that means V1 minus V2 is the V input, so that is equals to 0. So from there we can say V1 should be equals to V2. Okay, so that means if we are going to make V1 equals to V2 in case of ideal operational amplifier, the output in that case also there will be some finite value, or we can just say from here like if our system is there, operational amplifier is there, here we are having two different inputs. If we are getting some output at that time, the inputs are equal, or these inputs are called virtually short. That means if some output we are getting from the ideal operational amplifier, okay, at that time the inputs should be sorted. That means inputs, both the inputs should be equal, or we can just get from here like even if let V1 is equals to 5 volt and V2 equals to also 5 volt. If this is the case, at that time we are getting the behavior like both the inputs are equal. That means the internal resistance that is connected here in case of operational amplifier, R input will be equals to infinity, because ideal case input resistance is infinity. Okay, so if input resistance is infinity, in that case there will be V1 and V2 that will be like open circuit. It's considered to be an open circuit. So as this is the case, we are having V1 equals to 5 volt and V2 equals to 5 volt. That is both are equal, and at that same time that is the ideal one. So the input resistance will be infinity. If input resistance is infinity, that was basically connected in this way, like here this is called input resistance. So if it is infinity, it will be open circuit. That means both V1 and V2 are open circuited. So that means V1 and V2 are open circuited. So if the V1 and V2 are open circuited and both are equal, in that case this condition is basically called virtual short condition. This condition is called virtual short. Virtual short means because the input resistance is infinity, then it will be open circuited, and at that time V1 and V2 will be equal for the gain that is infinity, because it is an ideal one. So the V1 and V2 will be equal and it will be open circuited. So open circuited means both are connected to 0 and both are equal. That means both are virtually shorted to each other. Okay, so or we can just see sorted means both are having equal voltage. That means if it is 5 volt, both will be 5 volt. Both are, if one is 0 volt, the other will be also 0 volt, or one is 10 volt, then others will also be 10 volt. Okay, so this is called virtually short. So both the input terminals are virtually short if the operational amplifier is an ideal operational amplifier. Suppose if V1 is equals to 0 volt, if this is the case, that means V1 is grounded. If V1 is grounded, then V2 will also be 0 volt, or it will be grounded. Okay, and this is called virtual ground. This is called virtual ground, or this process that through which we are going to make this circuit to be virtually grounded is called virtual ground process. Or here, if it is virtual ground, means if we are having two different inputs, suppose one input is connected to 0, this is positive and this is negative, and this is V1 and this is V2, and this is your output, and here it is written like the operational amplifier is an ideal one. So it is written, it is ideal. If V1 is connected to 0, so whatever the V2 will be there, the V2 will also be equals to 0. Okay. So if V1 is equals to, because it is grounded, so V2 will also be equals to 0 volt. So this is called virtual ground. So this is called virtual ground. Okay. And salt, virtual salt means if one voltage is 5 volt, other will also be sorted. That means if it is sorted, the other voltage will also be a 5 volt. Virtual sort. Virtual ground means if one of the terminal is grounded, that means connected to 0 volt, next terminal will also be connected to 0 volt. That is called virtual ground. So virtual ground concept will be taking place when the op-amp is ideal. Okay, so this is virtual ground concept. The next we will see what is the case like if R input that we are considering. So in that case also, operational amplifiers, we have considered the input resistance to be equals to infinity. So here R input is considered to be infinity. So what is the effect of this? We will see. So we have seen this type of structure. This is V2 and this is V1. This is negative one. This is positive side. And this is your input resistance. And input resistance is infinity in case of the operational amplifier is an ideal one. Okay. So if this is an infinity, that means it is open circuited. If it is open circuited, suppose there is a current, I2 current is there, and this is I1 current. So if the IRI, that is input resistance, is infinity, in that case it will be open circuit. So if it is an open circuit, the current flowing through it will be equals to 0. Okay, so if the ideal operational amplifier is there, then I1 and I2 will be equal and it will be equals to 0 ampere. That means there will be no current flowing through this terminal, through this resistance, if the operational amplifier is an ideal one. So that we need to have consider while solving the numerical questions based on the operational amplifier that is an ideal one. Okay, so this was the case in case of ideal one. Now consider the case of practical op-amp. So now in case of practical op-amp, we will consider like for practical op-amp, the input resistance is not infinity, but it is equals to 10 to the power 6 ohm. That we have already seen. And also in that case, the gain is considered to be 10 to the power 6. This is for the case of practical one. Then suppose we are having now we are just going to have, then suppose we are having uh, output volt, that is 5 volt output, that means V output is 5 volt. Then the input voltage will be output divided by gain. So V output divided by gain. So V output is 5 volt divided by gain is 10 power 6. So V input should be equals to 5 microvolt. If V output is 5 volt. So from there, if we want to find out the current, so suppose we want to find out the current. So as the R input is 10 power 6 and V input is equals to 5 microvolt. Then current that is I will be equals to V input divided by R input. So V input is 5 microvolt divided by current is 10 power resistance is 10 power 6 ohms. So from there it is coming out to be 5, that is micro, and 5 again it is micro, and this will be coming out to be micro again. So it will be 10 power minus 12 ampere. So it is 5 into 10 power 12 ampere. So from there we can get like the current will be 5, 10 power 12 will be picoampere. So it is 5 picoampere. So I, that is current, is 5 picoampere. So it is nothing but equals to 0 ampere, because 5 picoampere, that is very less. So that's why it is considered to be very less, that is equals to 0. So even in case of practical operational amplifier, the output is coming out to the current flowing through these two input terminals, that is V1 and V2, these inverting and non-inverting terminals, the current is coming out to be 0. Okay, so from here we can just conclude like the virtual ground concept that we have seen previously is used for high voltage gain values only. So if we are going to use the high voltage gain, if voltage gain is also 10 power 6 and current, the input resistance is also current count to be like 10 power 6 ohms, then only we will be considering the virtual ground concept. So here we can conclude virtual ground concept. Virtual ground concept is used for high voltage gain value. So these high voltage gain values is basically like an infinity. If it is infinite, that is ideal one, or it is 10 power 6, or it is 10 power 4, or 10 power 3. Up to here we will be using the concept of ground in case of practical one also. So this is the case of practical op-amp, and this is the ideal op-amp case. So in practical also we will be using the case of virtual ground, but we will not be using in all cases. So where we will not be using, so it is not used if the gain is equals to 10 or 5 or 100 or 200. Okay, so if this type of gain is there, that is very less, then we will not be using the virtual ground concept. Here we need to analyze the circuit thoroughly. That means we not be using the virtual ground concept. Virtual ground will only be considered when the gain is infinity or gain is up to 10 power 3 in case of practical operational amplifiers. So this was the analysis related to operational amplifiers. Okay, so if the operational amplifier is ideal, we need to have the concept of virtual short. That means whatever the input voltage V1 will be there, the output voltage V2 will be the input voltage V2 will be the same. Virtually it will be sorted. Okay, if the one of the terminal is grounded, the other will also be grounded based on the virtual ground concept if the ideal operational amplifier is there. And this similar concept can also be used for practical case up to the case like if the gain is up to 10 power 3, we will be considering the case of virtual ground case. And also we can get like the current flowing through these terminals will be equals to 0. Okay, so even in case of practical one, we are getting the current that is very less. That's why we will be considering the current flowing through the input terminals of the operational amplifier will be always 0. We will not be considering input current to these terminals inside. Okay, so this was the basic concept of an operational amplifiers. The next point we will see what is the feedback. So now this is the operational amplifier without feedback. So without feedback means we have seen the gain bandwidth product. Gain bandwidth product is in case of ideal one is infinity, and also in that case gain in infinity and bandwidth in infinity. But if we want to have increased gain in case of operational amplifiers, we need to have a gain that is smaller. If the gain is smaller, then the bandwidth will be higher. So to operate these operational amplifiers for a high frequency applications, so for high frequency applications, we need high bandwidth or a smaller gain. Why? Because gain bandwidth product is always constant. So if we are going to increase bandwidth, we need to reduce the gain. Okay, so to reduce the gain, we will be using the concept of feedback. Feedback means output will be part of input. So we will be considering the output as a part of input also. So we need to connect output terminal with the input terminal. So that's why we will be going to have the feedback concept. So just from there we can see if it was open loop gain consideration. So open loop gain is AV, that we are considering the AV, or open loop gain is considered to be A open loop gain, AOL. So in that case, if this is the operational amplifier, it will be having a gain. So this gain will be like we are having the output and this is the input. Okay, so this is the input and this is the output. In that case, if we are talking about the open loop gain, so output voltage is AV multiplied by the input voltage. Okay, and suppose input voltage is here Vs. So V output will be equals to AV multiplied by Vs, or AV will be equals to V output divided by Vs. So this without any feedback or without any loop is there, so it will be AV. So this AV will be nothing but the AOL, that is open loop gain. So AV is the representation of a gain, voltage gain. If there is no feedback, that voltage gain will be equals to open loop gain. Okay, so here the open loop gain will be equals to V output divided by V input, or V input here is Vs. So we can get this as the open loop gain. Similarly, if we are having a closed loop gain, so a closed loop concept we want to find out, we'll just see closed loop gain. That means there is some feedback. So this closed loop gain can be of two different types. So that is positive feedback, or even could be a negative feedback. So what will be the effect of positive and negative feedback? We will just see. So we can just write other way so that it will be more interactive. Okay. So closed loop can be of two type, that is positive feedback or negative, or we can negative feedback. So if it is positive feedback, if it is in positive feedback, its feedback structure will be looking like a voltage gain is there, this is output, and this is input, and this is output. So output will be feedback to the input. Okay, so to have a feedback we will be having a adder. Okay, and the output part will be feedback to the input, and this input feedback will be having some gain. The feedback will be having some gain, so this gain is called beta. Okay, and here it is coming out to be, so this is your input Vs, that is uh, added with the output with again beta. So here this is the terminal that's called beta into V naught, that will be positive or negative. So if it is a positive one, it will be a positive feedback. If it is negative, it will be a negative feedback. Okay, so the structure we can represent it here. With again beta, and again this is output, this is input, and this is Vs. So this, if it is negative, that will be a negative feedback. Okay, so we will just see what is the effect of these positive and negative feedbacks. So if we want to calculate here, so the input voltage in that case will be, so this is the input voltage, that is Vs. In the case of positive, it is plus beta times V naught. So this is your input voltage, and similarly the output voltage will be gain multiplied by input. So it is gain multiplied by input. So input is nothing but Vs plus beta times V naught. So from there, if we separate the V naught term and we plot, we just write like Vs V naught by Vs, it will be coming out to be AV divided by 1 minus beta times AV. Okay, or from there we can just see it is 1 minus beta times AV. So 1 minus something is there, that means this denominator term will be less than 1. So if it is less than 1, if we are dividing AV with less than 1, there will be some value that is greater than AV. So this is like, it will be greater than AV because it is, we are dividing AV with some smaller value less than 1. So this VOL VO divided by Vs, that is output divided by input, will be considered here as closed loop gain. So that is V output divided by Vs will be equals to AV divided by 1 minus beta times AV, and this closed loop gain will be greater than AV. That's why it is called positive feedback, because in positive feedback the gain will be increasing from the open loop gain. So open loop gain was AV, now the closed loop gain is coming out to be greater than AV. So this is called positive feedback. Similarly, we will be analyzing the negative feedback also. So in case of negative feedback, the input voltage will be considered to be Vs, and this is negative, so it will be minus beta times V naught. And again the output voltage will be coming out to be AV multiplied by Vi. So AV multiplied by Vi equals to Vs minus beta times V naught. So from there we can just get the relation between V output by V input. So it is coming out to be AV divided by, instead of minus there, it will be plus. Okay, So this is your V output divided by V input. So here this gain is called A closed loop gain, that will be equals to V naught divided by Vs, and here it is AV divided by 1 plus beta times AV. So on the denominator side you can just see 1 plus beta times AV. So 1 plus something will be greater than 1. So if we are dividing AV with respect to greater than 1 value, it will be coming out to be less than AV. That means here in the negative feedback case, the ACL, that is closed loop gain, is less than AV. So less than AV means we are able to reduce the gain of the amplifier. Okay, so if we are able to reduce the gain of the amplifier, so that reduction will be depending on the beta value, so beta factor. So based on the beta factor we can reduce the gain of the amplifier, and if we are able to reduce the gain in closed loop system, the bandwidth will be increasing, because gain or gain, closed loop gain multiplied by bandwidth, is a constant. So if AV or closed loop gain is being able to reduce, then bandwidth will be able to increase. So if we are able to increase the bandwidth, now we can use this amplifier for high frequency amplifier or high frequency applications. So this is how we will be using feedback, negative feedback system to use for a high frequency application in amplifier case. But the use of positive feedback is like it is used for, because we are able to increase the gain. That means we can use this positive feedback in case of oscillator design.
Excuse me, sir.
Yes. Yeah, it is
Sir,
over now. Yes. So positive feedback is used in case of oscillator design, and negative feedback will be used for high frequency applications in case of amplifier. So amplifier design for high frequency applications. Okay. So this is all about the class. So thank you, and from next class onwards we will be having some other topics. So just we will be discussing the concept related to operational amplifiers, its applications, how this operational amplifier can be used for different applications. So thank you, and try to submit the feedback form that I have provided.
Okay, thanks.
So yeah, if you have any query you can ask. Otherwise, yeah, thank you.